A snooker player can make a white ball stop immediately after hitting a red ball. This technique is called a stop shot. Let's watch a demonstration of a stop shot. Does the total momentum of the white ball and the red ball conserve before and after the stop shot?
In example 4, the collision between two snooker balls is perfectly elastic. Both the total momentum and the total kinetic energy are conserved. The result of the calculation shows that the white ball will stop right after the collision, while the pink ball will pick up its velocity. This is called a stop shot. You may test the result by using two identical coins at home pretty easily. In example 5, two trolleys collide and their velocity time graphs are given. You may find the velocities before and after collision easily from the motion graphs, as both trolleys only move towards right. All velocities should be positive. You may easily verify the conservation of momentum from the tabulated experimental result. 3. Examples of conservation of momentum. A. Newton's cradle. Newton's cradle is a toy that can demonstrate the conservation of momentum. And since the collision between the steel balls is almost perfectly elastic, there's also conservation of kinetic energy.
Pull ball 1 to one side and release it. Pull balls 1 and 2 to one side and release them. Pull balls 1, 2 and 3 to one side and release them. Pull balls 1, 2, 3 and 4 to one side and release them. Pull ball 1 to one side and balls 4 and 5 to the other side and release them at the same time. Pull 2 balls to each side and release them at the same time. Pull ball 1 and 2 to one side and ball 3, 4 and 5 to the other side and release them at the same time.
In example 6, you are asked to prove something never happens. You may prove by contradiction by applying the conservation of momentum as well as conservation of energy to do so. B. Recoil of guns and cannons. When a bullet is fired, it is similar to an explosion. As the bullet is fired forward, the gun and the man holding it recoil, which means move backward. The recoil's speed is much less than the bullet's speed because the man holding the gun together is much more massive than the bullet. In example 7, the recoil speed is calculated. The actual recoil speed is even smaller as the mass of the man holding the gun should be included in mg. C. Spacecraft. A rocket pushes gas downwards to produce an upward thrust on itself. Similarly, the electric fan of a fan cart pushes air to one side, and so the air pushes backward on the fan cart in opposite direction. Similar principle also applies to helicopter, which pushes air downward to attain an upward force. A saver is simply a mobile ship that has 24 nozzle thrusters, which work like small rockets that eject gas in different directions to give propelling forces to the astronaut. 4. Momentum not conserved. In this chapter, you have learned that the total momentum of a system is always conserved. While in daily life, when something such as a car accelerates, the momentum of the accelerating body keeps increasing. In fact, anything accelerating would have a changing momentum. So, does it violate the conservation of momentum? The answer is No. The total momentum of a system is conserved only when no net external force acts on it. When the car accelerates, there is friction acting on the car by the road, so the momentum of the car itself is not conserved. In figure 7.1g, when the man walks forward on a small boat, the boat is pushed by the man backward. The total momentum of the man and the boat is conserved. So, when the man starts walking to the left, the momentum of the man increases in the left direction, while the momentum of the boat increases in the right direction. In figure 7.1h, when the ball hits a desk, the ball stops and its forward momentum disappears. In fact, its forward momentum is shared with the desk, and so the desk moves forward a bit. If the friction between the desk and the ground is large enough, or it is a wall or a building but not a desk, the forward momentum of the ball may even share with the earth. This explains the case when a car collides on a wall, and it seems that all the forward momentum of the car disappears almost at once. So when we walk forward, the ground is pushed backward by us. The ground is literally the earth, and it is very massive, and so you can hardly observe the ground moves backward easily. And now do check point 2 on the next page.